Let's get started. So, all of my endeavors in computer systems, I've always called them experiments. So this is another recent but successful experiment. The features are that I've got a PC, a server.
Kumar,
Yeah.
if you do a slideshow, I think it'll show up a little larger for people.
Okay. Hold on. Right there.
Yeah.
So I have a home computer, which I'm using right now and coming through. But it also has a lot of files that we want to keep personal. We want to keep within our ecosystem. So we needed a method by which we could back this data up to a remote location such that it's not, the backup isn't inside the house. We wanted it to be at least several miles away. And to be backing it up to another Ubuntu running NFS, Network File System, but that's running on basically a Raspberry Pi 4. We want to be able to connect to it via Secure Shell, SSH. Want to do the backup via rsync. So how this has been set up is the RPI has an extended 4 formatted USB SSD, solid state disk, inside which there is a Linux Unified Key Setup or a LUX encrypted file. And this file stores all of the backup folders and files. Of course, my primary objective always has been use free and open source software. And I definitely did not want to be reliant on any cloud-based storage. Okay. It needed to be a low power consumption device and quiet, physically stored, as I said, in a location of one's choosing, small and reasonably portable, and a capacity that one's budget will allow, from hundreds of gigabytes to more than a terabyte. Should be affordable and incur only the initial cost, no subscription fees. Of course, you'll need an internet connection at both locations, which is generally not free. What was the need? As I said, we wanted to, do backup of family data, which we physically possess. This data shouldn't exist anywhere but within the family. Why did I use this? Because I've used LUX, or Linux Unified Key Systems, on Linux computers for more than a decade. It's very reliable. I've been using it day in and day out with multiple devices. Many of my computers are inherently encrypted, so even if they get stolen, you can't even boot them up without, cracking into it or just reformatting and using it as something else. But of course, we have to realize the limitations. The limitations are this backup method is only as good as the storage location of that SSD, that remote SSD. If the SSD is corrupted by, either premature disconnection, data could be lost, power failure, data could be lost. The SSD itself fails, the data could be unrecoverable. So any myriad of those failure points do exist. So therefore, a cloud service provider might be the better alternative for people. What are the features? I apologize, this is going to be small, so I'll read it for you. And of course, I'll share the presentation later, so if you can't catch something because the lettering is too small, you'll be able to read it later. So it's fully end-to-end encrypted backup using nothing but bash, rsync, and SSH. It's, of course, remote storage. It could be one or multiple clients backing up to one server. In other words, multiple computers could be talking to this Raspberry Pi. I have only one-to-one set up right now. The backup partitions that grow and shrink as needed. It's fully auditable storage. And by the way, all of this I learned from the website link I provided. This is the guy that talked about it. He's done an excellent job of documenting it. I just implemented what he had put together with some enhancements. So how does it work? The remote server has a plain partition that stores one or more sparse files. I have only one sparse file. That file contains a LUG's encrypted partition inside, and inside it are the backups. So before each backup, the client mounts the plain partition over Secure Shell, then opens the encrypted file and mounts the partition from inside it. Then it backs up the data, performs the unmounting in reverse order, such that the remote server never sees the unencrypted data, since SSH is providing encryption in transit and LUGS is providing encryption at rest. I'll go into some more details. I'll pause here for some questions. All right. So here's a simple schematic. So here's my home source PC. Theoretically, it's in a local what do you call it? IP address. There's a home router, theoretically with an external IP address, connecting to the remote router at a different external IP address, which in turn is connected to the remote Raspberry Pi at its own local address.
Kumar, the remote router, does that have a static IP, or how are you finding that to connect to it?
Good question. No, it does not have a static IP. And yes, that is a source of trouble if that IP were to change.
Okay. You could use a dynamic DNS service to get around that, so that anytime the IP changes, it would automatically update that service.
I know, but I have not, I have not really found something that is reliable, working, etc. I've dabbled in it, but if it changes, I'll call up my daughter and say, okay, daughter, go to a website, tell me what your WAN address is, or something like that.
Sure.
Yes, it is one of the problems. I agree.
A poor man's way to do that. I had my remote system, whenever it detected its IP address change, it would just email me the new IP address.
Yeah, nice.
Okay. Yes, good idea. So what is the hardware? It's a computer running 2404, which let's say we call that the home. And it periodically and automatically saves data to the remote Raspberry Pi 4. The Raspberry Pi 4 is running Ubuntu. Happens to be 22. But it boots from a USB SSD. ext4 is the backup, computer, ext4 being the file system. Now, I'm not going to get into exactly how to set the Raspberry Pi to boot from the USB SSD. There are lots of videos or help guides that teach you how to do it. I think Raspberry Pi 5, if I remember correctly, you don't even have to set up anything, and it just boots up from the USB rather than the SD card. But the one thing I do know is that some USB drives will not boot up through the high-speed USB. You have to connect it to the low speed. Such is the case with my Raspberry Pi 4. There are some combinations of USB hard drives that don't work nicely with the Raspberry Pi 4 on the high speed.
Does it expect PCI Express 3 or PCI Express 4?
Sorry, I didn't quite catch that, please.
There's just, most of the new SSDs are PCI Express 4. You have to get older ones unless it's PCI Express 3.
Ah, I see. Thanks.
I'd watch that actually.
It's a function of the USB to this.
Those are not USB based.
So the adapter or yeah. It's just an adapter.
Yeah,
Okay.
if you could just put something in the chat so I remember that, I would appreciate it. Thank you. Okay. I divide this presentation into two parts. Section A, what you're going to do in the home computer, and B, that you have to do on the Raspberry Pi. First of all, I would say set this up locally in one location where you're trying all of this out before you move it onto a remote location. Make sure it works locally. All right. On the home computer, you're going to create a private/public key pair. I used ED25519. I won't go into the details of that. You, of course, need to install rsync and write a suitable script for doing the backup. I don't go into that either because it's going to vary from person to person as to what they want to back up and so on and so forth. You're going to create a suitable mount point for the remote NFS file system to be mounted on. And then you're going to configure cron tab, create shortcuts, icons, etc., which are kind of the finishing touches for everything to work nicely, seamlessly, automatically, and so on and so forth.
Kumar, for those who may not be familiar with rsync, could you quickly mention what that is and why you used it?
rsync, remote sync. If somebody else is better qualified to answer that question as to describe what it is, I'd appreciate it. Basically, it's like a backup program where you can say, here's my source folder and here's my target, and make sure that whatever files are not on the target, make sure that they get backed up. It uses a variety of methods each of which is configurable to say, how do you know what is different? So you could ask, check by file sizes, check by date of creation, data modification, etc. More than that, you can say, here, look at this text file where I'll give you what all files or folders ought to be included in my backup strategy. You can use wildcards. You can also have a list that says exclude these type of files. So if you have star.back files or squiggly files, you say ignore all that junk when you're doing the backup of an entire folder. So it's very, very useful, very, very powerful, very, very reliable.
Yeah, for me, the main thing is that it's very efficient. Once you've done the initial synchronization, then any subsequent changes, the subsequent runs, it merely synchronizes the changes rather than the whole thing.
Thank you. Key point. I forgot about that. And by the way, there is also a rsync that is a GUI dressing on the rsync. And so if you don't know what you have to type in the command line, go just do a sudo apt-get install rsync, and then you get a menu. And then when you do a trial, it actually shows you the command line that it would have run. So you could now say, oh, okay, that's how I need to write the command line to do what I just asked it to do through the GUI.
And rsync's available on most Linux distributions, I believe, too.
Yep. Out of the box, installed. It's there.
Yeah, and rsync can use FTP and HTTPS as transports as well.
I didn't know that.
Yeah.
Nice. Okay. So create the key pair. There's the actual command. If you had to install rsync, I use gedit, etc. Just sudo apt-get. Oh, I forgot the word install. That's how you would install packages, any packages. I also created a bash script, and you would want to probably create it in home/user, saying, hey, this is how I want you to do the rsyncing. I'm not going into, the details of how to write that script, but essentially you would want to write the script such that it backs up what you need backed up. And finally, there's a cron tab entry. Make sure that this is being run as sudo, because I back up not only just my files, but files of other users. So therefore, running it as sudo is essential so that it'll back up other users' files as well. So that's an example of how to set up cron tab. Let's go on to the remote. But before I go there, any other questions or comments or helpful tips?
I was learning about, can you explain sudo, just a quick summary of what it is?
Sudo is switch user and do something. And peculiarly, if you don't say anything, then sudo implies that you want to switch user and become the root user and pretend that you are the root user when you're doing the subsequent command, namely cron tab -e. So therefore, when you say sudo cron tab -e, you're editing the cron tab file or the chronological tabulaton or table of events that need to be run, but events that need to be run by root. If you did not say sudo and you just said cron tab -e, then you're altering the chronological table that pertains to that user, the user that is logged in. That's the difference. Did I answer your question?
Yes, thank you.
Okay. Now for the remote on the Raspberry Pi. Okay, so you're going to install Ubuntu on your Raspberry Pi, and there is a really handy.
Your phone.
Was that a question? Sorry.
No.
There's a handy installer, a Raspberry Pi installer. Go look it up, do a search. You'll find you can download it. It's available as an app both for Windows computers as well as Linux. It's an easy way to burn the SD card or even the SSD with a Raspberry Pi operating system of your choice. So if you haven't used this before, if you came from the days of Raspberry Pi 3 or just Raspberry Pi when they didn't have such a tool, it was not that easy. This makes it a breeze. The next point was configure the Raspberry Pi 4 to boot from the SSD, not the SSD card. Sorry, not the SD card. And then configure fstab, the file systems table, to use tempfs for various log files or log folders. I generally do this because I don't want to wear out my SSDs by constantly writing to them these useless log stuff. In my opinion, useless because, it's just a Raspberry Pi. I don't seriously look at those log files anyway. You'll need to configure UFW, or the Unified Firewall, which is your firewall software, to allow incoming secure shell connections. And then you're going to copy the public keys from your home PC, which you had created earlier, the ED25519 public key only, not the private. And then you're going to set up a LUG's file image. Once you've done that on the Raspberry Pi, you do have to configure the remote router to port forward an incoming SSH connection to the Raspberry Pi. Let me go back to that diagram that I had shown earlier, right here. So on this remote router, you have to say that, hey, any incoming SSH connections coming from wherever, please do forward it to the local IP address 1.20, which is where the Raspberry Pi 4 is running. I'll pause there for any questions. I'll go through some of the details of these 6 steps.
Thank you for spelling out what those command acronyms stand for. That's very nice.
Good, thank you. So you're going to configure the secure shell daemon. This is the background job that runs and allows secure shell to be accepted and coming in. And you're going to then configure its file, the config file, which resides in the etc. secure shell, and the file itself is the secure shell daemon _config. You can use nano, which is a really nice, small, very rudimentary, but very efficient editor. I'm not a big fan of VI. Therefore, I use nano whenever you don't want a GUI up front, but you want to, you want to edit just at a terminal, simple terminal. So you're going to make sure that the following lines exist and they are set correctly. Essentially, you're going to say you want to permit root login. And secondly, that public key authentication is permitted. And the key that is going to work will be stored in the .ssh authorized key file itself. And just save the file. Once you've saved the file, make sure that as sudo, namely pretending to be root or becoming root, you're going to start the system control command to restart the secure shell server. Moving on to the unified firewall software, you're going to then tell it to allow traffic locally, because, remember, you're pretending to be sitting in the remote side of things, that locally it should allow secure shell connection from anywhere local. That's why the /24, namely the, what do you call it? The smallest subdomain that you want all 0 to 254 addresses to be permissible. The next step is you're going to also add another rule that says you're going to allow it from 500.1.1.123 to any port, and this is where I really need to change this to XXX, whatever you want it to be. Let's recap.
That's the address of the first router.
Yeah, I'm getting to that. Yeah, hang on a minute.
Okay, all right, go ahead.
I'll explain it. So I want to go back to my diagram. Remember that I said 500. 500 is my home computer. 600 is the remote. So subsequently, without me referring to these diagrams, remember 500 is where I'm coming from. 600 is where I'm going to remotely. 10 is on my local side and the local IP. 20 is the local on the remote side. I've tried to keep that nice and easy for people to follow. Did I answer your question?
Not exactly.
Then sorry, what's your question?
So traffic that's coming in to the remote router and then being routed to the Raspberry Pi. Is that? No, I'm confused. Go ahead.
Okay, so let me reiterate. Remember that all of this is being done on the router that's sitting at 600.1.1 something. This is the remote router. I'm telling, sorry, not the remote router, the remote Pi, the Raspberry Pi. I'm telling the Raspberry Pi on the remote side that if there is an SSH coming in and it is asking for a connection to some port, only if it is originating from 500 are you going to permit it. In other words, that Raspberry Pi that's sitting remotely will not accept any SSH connection from any other IP address.
Does that mean if you want to run this from multiple houses where you're backing up to a single location from multiple remote locations, that you'd have to add additional allowances to those other remote locations?
Absolutely, yes.
Okay. And if your IP address changes, if you don't, in the remote location, you don't have a static IP and yours changes, do you have to have them have, how do you get in then to change this?
That's when I'm going to be calling, that's when I'm going to be calling up my daughter and saying, daughter, will you please go follow these steps and change the firewall rule, blah, blah, blah. As I said, there are points of failure.
Does this work with IPv6?
I have no idea.
You
got remote hands on site.
Because I think we can all get static IPs for IPv6. There's enough of them out there that they hand them out just willy-nilly almost.
Really? Haha.
There's a lot.
I know there's a lot, but I didn't know if my ISP would say, oh yeah, if you want IPv6, we'll give you one for free. Or for whatever you're currently paying.
Yeah. Anybody know that?
Probably varies by ISP. Yeah.
Yeah, I think Spectrum supports IPv6. So, I know you have to turn it on the router.
But will they give you a free static address? Hard to say.
Yeah, I don't think you need like to NAT with an IPv6. So that's like, yeah, everything's kind of essentially has a public address.
Right, but it's got a rule to allow in only connections from the home router. So you have to know what the address of that is, and if it changes.
And he's allowing the public IP addresses. So yeah, if it was an IPv6, it would probably stay the same then if it's just because it's that device. I think that has its unique address.
So IPv6 tend not to change, like.
I believe that's correct, right? Is that right? You looked into it. That's much.
I looked into it a bit.
That was my understanding, at least, like IPv6.
Well, we might be.
Yeah, sorry to change it.
Yeah.
We have to do a presentation on IPv6.
We might be going off the rails a
so.
bit here. Maybe
Sorry.
we could continue the discussion about whether how IPv6 would affect this offline.
There's a whole mobility.
We'll let you go ahead, Kumar.
Okay, Now I'll explain step by step the bash script. I walked you through the process. Open with, let's try Pluma. Can you see my script file now?
Yeah, it's very small.
Yeah, hang on. I will try to enlarge this.
Okay.
Edit. Preferences. Fonts. Editor, colors, blah, blah, blah. Oh, now I know. There we go. Is that better?
Oh, yeah.
Yep.
Good. So again, I refer to the person that had written from where I got the inspiration, the ideas, etc., etc. I will share the script as well.
Nice. That'll be helpful.
Yep. Without it, my talk would be rather puzzling.
Ready to repeat.
So I walked you through part A and part B. So let's go through part A. This is in the remote Raspberry Pi. So just be safe. Just to be safe, copy your SSHD config file. You can put whatever thing. I generally put .original, and then I edit it. And essentially, you're going to find the line that says port 22, which is the default SSH port, and change it to something else. Some 5 digits. Make sure it's less than 65,535. You're going to alter your firewall rules. I had shown you those examples previously, so I just repeat them here. You're going to restart your SSH server, and then you're going to test whether you can get to it or not from somewhere else. And if you can, fine. Delete this firewall rule if you had created it. Essentially, what you're saying is, I don't want somebody coming in through the standard port 22. Why? Because most port sniffing activity happens within the first 100 or the first 1,000 ports. So I tend to switch it to some 5-digit port. Next, you would want to set up the root password. So make sure that a root password is set. Also, you want to make sure that in the SSD config, the root permission, like I talked before, is done, etc., etc. This seems like a repeat of the same thing I've said before. When we talked about the home PC, this is how you generate the key pairs. You would create it for the standard user as well as the root user. So you're kind of repeating the same thing in a slightly different manner. So now you've got the 2 key pairs. You're going to copy it to the Raspberry Pi 4. This is how you would copy it. And test that it works. Copy the root public key. Check that you're able to log in as root onto the Raspberry Pi. You will also configure the secure shell file system to permit all mounts as a non-root user. So again, copy the FUSE or fuse.conf as something suitable. Use nano to edit it, and essentially uncomment the line user_allow other. Save the file, etc., etc. Okay. Now you're going to, from your home PC, this is from the home PC, you're going to do an SSH file system and open and say allow other user. You're trying to connect to the remote Raspberry Pi. I want to basically mount this. This is where I've created that file, and I want to mount it locally called home/backup. So this needs to exist on the Raspberry Pi, and this needs to exist on your local computer. And basically, you're just connecting to the two file systems together. Once you've done that, you're going to create a sparse file that will hold your backups. You can indicate a maximum size, but make sure that it is at least 25 megabytes. I made it 750 gigs. So this is how you would create that file. Notice that it has the LUKS extension. Make sure that the user owns that particular file. Change permissions on it. Make sure that you are able to see it and that it exists, etc. This is just a test. Now you're going to create the DLUG key file. This is on the local, again, on the home computer. You make a directory suitably off of the root folder and in a folder called .key files. And you're going to create a random set of numbers inside this backup key. Make sure that it's suitably large. I used 4096 bytes. And the count means just do this once. And namely, there are 4096 random characters in it. This is going to be your key file, this backup.key. This is the one that locks or unlocks your DLUG file. Make sure that you set the permissions properly. Check it by just listing it. Once you have this key ready, you are going to now create the, whoops, sorry, hang on. It's out of the way. You are going to create the DLUG file itself using the key file that you had created. And it'll give you this warning. Hey, you're going to overwrite everything, blah, 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 etc., etc. Once you've done that, you can then open this file that you've created. You're setting it up by naming it backup partition. That's just a name. But what that does is, when you go to the next command over here and make fs or make a file system of the type ext4, it is going to create a mapped file as a device called backup partition, and it sits in the /dev folder /mapper folder. So essentially you're mapping this backup partition to connect to the home backup /backup DLUG file that was created with a key. It seems complex, but it works. If you ask me, what does this lazy IT table init do and the lazy journal init do? Truthfully, I don't know. It's something that I need to investigate, but I haven't. My guess is it has to do with the index tables and the journal file system that exists inside ext4, because ext is a journaling file system. That's the extent of my knowledge. All right. So once it has done all of that, you're going to create a mount point locally. I call it backup-rpi4. I ensure that I have permissions that I'm the owner of this folder. Then I'm going to mount the dev/mapper/backup partition to this mount point /home backup RPI4. And I can open that partition. And if everything works and you list what's inside it, you should be able to see perhaps just nothing. But in my case, because I'm, doing this all on a system that's already been done before, there's a home folder, there's a lost and found folder, and so on. But I also created 2 just 0-length files with these names in them, just so that if everything works right, you will see these files. The connection has worked if you see this and kind of thing. I use this subsequently in scripts to say, if it is able to open things successfully, then it should be able to see these files, and I know that the whole thing worked. So that's why I say these last 2 files were created later on after my initial setup to ensure that decryption is working correctly. Now you're connected to the remote system. It will behave like a local system. It will be like this here, as if it's local. And therefore you can, rsync anything. You can list files, do whatever you want as if it's a local file system. So run your backup. After the backup is done, you use these 3 commands below in that sequence. You first unmount your local file system or folder. You will close your LUG's mapped partition, and you will unmount the home backup-RPI4. If you want to connect subsequently, forget everything that I had talked about earlier. This is all you need in this sequence. You are going to secure shell file system through your dedicated port, allowing other users to secure shell in. You are going to connect the 2 file systems, the remote to the local. Next, you're going to open your LUG's backup that sits inside there using the key file that you had generated, kept, etc. And you're going to mount it as a mapped device. And that mapped device, subsequently, you are mounting to a local file system. All of this works reliably. I've been doing this for probably now 30 days, a little more than that, completely unattended. It has worked every time. So I recommend that you take these, those above scripts, and you just make yourself your own script. One for disconnecting and another for connecting. The basic steps are done. So it takes a bit of doing, but if you follow this, I think I've got it right. I may have made some mistakes, but if there are any, please do ask me or refer to the guy that I have, mentioned earlier. And you should be able to get it working. Any questions? I'll move on to showing this live.
Sean has a question.
Yeah, for the I know you said one of your requirements was like low power, and you
Yeah.
chose the Raspberry Pi. And then I was curious kind of on the 4, if what the choice was versus like a 0 or a 1 or Pi 5, all the various models, if you considered it, or if it's just what you had on hand, or
What I had on hand. I do have a 0, but this was something I knew. I've done it before. It was working for me locally. And because it was a local backup, I said, okay, I'm going to take that leap into making this completely remote.
Makes sense.
I'm quite confident there's nothing here I see that needs the horsepower of a Raspberry Pi 4. The bottleneck is the internet speed,
makes sense. Thanks.
But I would also recommend while you're setting all of this up locally, do your full backup that you want to, so that rsync becomes that incremental mode and makes it easy on the subsequent transfer process, like Grant had stated. Of my experiment, or description of my experiment. Any questions?
Have you had any errors or disconnect behavior, or like you haven't, or I guess it doesn't really matter, it just rsyncs later, or any like in-flight disconnects?
So far it hasn't. So far IP addresses have not changed. But as I told you, I've been running this only for about a month. I'm sure IP addresses will change sometime or the other. And therefore, I would have to go through resetting the UFW rules.
Is there any way in setting those firewall rules to use DNS names rather than IP addresses?
Here's what I would probably do. Is if I know the DNS name. No, hang on a minute. I don't think UFW accepts names, but I could be wrong.
Probably true.
Probably just look them up though, if you do have like a dynamic DNS, like you were saying earlier.
Right, but then you'd have to have something that periodically checks and changes
Updates
the
the rule,
firewall
yeah.
rule, yeah. Which you could.
I'm sure there would be a way.
Yeah.
Since you can look at the etc host file, or you would alter the etc host file, that could be your single source of truth, but you're altering the etc host file by finding out what it is and so on and so forth. I'm sure there's a way.
Yeah.
In fact, today I was trying to find out, is there any way I can get my external IP address without resorting to looking up some website, like, what's my IP.com or something?
I like
Does anybody know of a way?
There's one site, it's like has HAZ IP. So like IP.com. That's the one I like to curl. It'll just give it back, and like if you're doing it like in a bash script or something.
Yeah, but I'm talking even more pure than that. I never want to go outside and have somebody look in to tell me what my IP address is. I don't think it's possible, but I'm just asking the question.
You'd have to query your router, I think.
You might be able to do a trace route and record the path.
I tried that, but the trace route only says what the hops are going outside. It doesn't tell me specifically what my outside is looking in. It tells me I'm going from 192.168. Whatever I am, or 1.1 to hopping outside.
What kind of router are you using?
You're right. I can inquire of the router. I
Okay,
don't remember right now.
okay.
I've got 2 or 3 in around the house, and I don't remember which one it is.
Gotcha. Yeah, I mean, mine is open sense, so I know that I could SSH into it, do
Yeah,
some
got
kind
it.
of a command to show the interface, and then
Yeah,
do some
API call too.
sed or awk or whatever to pull out the IP address. Yeah,
Right.
all that, like that.
There you go. That's the.
It's like kind of scratching your right ear with your left elbow, but it gets there.
Yeah, I just curl if config.me.
okay. So got it. That's an outside source. Got it.
Right.
Oh, so somebody grabbed that kind of a website name, huh?
You decided to do what we call?
Oh, I guess there's two of them, but.
We write down.
I put it in the chat.
ifconfig.me.